the GM cosine and the two S-shaped model. So the GM cosine are our proposed model. So we are comparing that model with the performance of the GM11, the S-shaped 1, and the S-shaped 2. Here is the result of our modeling. As you can see on the figure on my right, this is the performance of all the model, where the blue dots here are our average PSI, the observed data. And as you can see, the gray line that follows the data at our proposed model, the GM11. As you can see, the red line is the the green line is the GM cosine, and the red line is the GM11, and the yellow line, the green line that is overlapping is the two S-shaped model. And the same value for that estimation here, or the fitting, is right here, shown here, where the highlight is our model. We also went ahead and did a four-step prediction, which is a short-term prediction, to see how our model perform also. So from here, it's based on the data, we see the fitting, but we didn't have sufficient data to do to verify our four-step prediction. But as you can see, our proposed model, before the short-term prediction started by year 9, so that our data kind of follow the trend in the observed data. And because the PSI follow a monotone decrease, you can see that, and even the other the GM1 also follow that trend. But as you can see, the S-shape 1 and 2 follow the trend, but the first step, we can see the PSI here kind of from 2 we have 0 for the Arizona DOT model, also South Carolina model, and here for the North Carolina model, we can see from 3.7 we have to jump 1 unit. According to since the work we have been doing with the DOT and being at the DOT, according to Mr. John, what's at the DOT, they say PSI cannot really, in a matter of 1 year, PSI cannot really jump like 1 unit dramatically below. So that means like it's unusual here. So we can see our model kind of follow that trend. Also, here is the parameters we use to estimate to estimate those numbers I showed you earlier. Those are the parameters for all the model. And as you can see, our the mean absolute percent error for our proposed model outperform the other model. Also, we try to use that parameter to do a long-term prediction. Long-term based on in what year the the PSI will fall to 2.7. In South Carolina, a payment rehabilitated when you reach a PSI value of 2.7. We set up our equation what year, based on our parameters, the PSI will reach 2.7. As you can see, our proposed model predicts 17 years, the GM predicts 16 years, and the two actually 9 years. And according to the SCDOT term, this is the first treatment with asphalt, with the pavement asphalt. According to the term paper, is supposed to give it estimate of 20 years, and according to our research we conducted here with Dr. Mullen and Dr. Owen, we found that it's supposed to give like about 24 years. So we can see the GM model is not quite there, but it's reasonable then compared to the two other methods. This is the same method, the same treatment, but on asphalt over concrete pavement. Same thing, same fitting result, and same result here. As you can see, the four-step prediction, the short-term prediction, the GM follow that same monotonic decrease. And the only thing with the GM we notice, you can see fluctuation from you have 4.1, 4.0, and go back to 4.1, 4.0. But we have a solution, we propose a solution for that one as well. And the parameter obtained are here, and we can, as we can see, our map is better compared to the two S-shaped model. And in the long-term prediction, we have 24 years for our model, and this model, according to the term, is supposed to be about 15 years, but according to our ongoing project, it gives us about like 20 years, which is 20 years. Okay, this one's supposed to give us 24 years, according to our ongoing method, and the duty, according to the duty, 20 years. So we see the GM model is right there. And this treatment, now we have our second treatment. We see the middle of 2 to 4 inch plus 200 PSY for asphalt pavement. Same thing, we can see here how the proposed model and other model kind of follow the trend for short-term prediction. And the parameters are here, and we are made